Hello friends, in this video we are going to be looking at a number of project management techniques, but we are going to localize our discussion on critical path method and program evaluation and review technique. So we are talking about CPM, or what we call the critical path method, and we are talking about PERT, which we call program evaluation and review technique. So all these methods are very important in planning, scheduling, and controlling project durations, costs, and a number of other things like resources. But majorly we are looking at time or duration of activities that later on translate into determining the overall duration of a project. And that's what majorly CPM does. For PERT, usually we are looking at how much time each activity or each task is going to take. And therefore, we can say that critical path method is a project management technique that is used to plan, schedule, and control projects which have got deterministic durations. In other words, those are certain or fixed durations. But in part, we are talking about planning, scheduling, and controlling of uncertain projects where durations are probabilistic. So in this discussion, we're going to be looking at the predecessor diagram method and critical path method. The predecessor method is actually what we call the activity on node. And the critical path method, we are calling it the activity on an array. So for that matter, let's look at this guiding question and we'll go through it. So consider the following workflow below. Activities, you have A, design approval, material procurement, assembly, up to packaging and shipping. Then we are given the sequences. So that means A is the starting point and B follows A, meaning that also C follows B. Then we have production following C. We have we are told that D follows C, and then this E, quality control, depends on D, and then packaging is the final activity. We are told to draw the arrow, the activity on arrow and activity on node diagram to determine the earliest time and finish times for each activity, and then identify the latest possible time and finish times without delaying the project. So we are told also to determine the critical path and then determine what the project's duration is going to be. So extracting the information from above, as we have said, A is the starting point with 10 days, then is followed by B, okay, B, C, D up to F, but we are also told that procurement B and assembly line C occur in parallel after A. So it means you can't do B minus finishing A, you can't do C minus finishing A up to E. I mean up to F. So let's right away look at how we can get the activity on node diagram. So we are going to draw, first of all, let's first pick those activities. So when you look at A is a starting point. That is if I'm talking about activity on node. So we are beginning with A, and this A is, after we have finished A, that's when we can do B, that's when we can do C. Then also, after finishing C, we can do D. So we can do D after finishing C. And after finishing E, actually after finishing D, we can do E. And after finishing E, we can do F. Of course, this was never told to us, but we are told that quality control E depends on D. Quality control E depends on D, meaning the predecessor for D is actually, for E is D. And the final activity is F. So for us, we are going to move away from E, we go to F. So from E, we are going to F. That's what we are going to do. And then, this is basically how this activity on node is going to be working. So this is the final activity, and therefore it is always a good practice to close the network. So you start from A, you end at F. So meaning you can look at the number of days that you're going to take. So you indicate everything on those nodes, and then later on you proceed. So let's now do that by, since we are told that we need to calculate the earliest time and finish times for each activity, then we are going to do this in details. Remember, we have something like this. So here you have activity and you have the duration. Then you have the earliest time, this is the earliest start time, earliest finish time, latest start time, and latest finish time. So once we do that, we know that the earliest time, that is actually the earliest time, okay, that we can start. This is the earliest start time. So the earliest time we can start without delaying the project. So without delaying the project, we know that A, since it is a start time, that's where this is the starting point, meaning that our starting time is going to be 0. So since A takes 10 days, that means the earliest finish time without affecting the project completion, we are going to say this is 0 plus 10, and we shall get 10. So what we are going to use here is a forward pass and a backward pass. So in the forward pass, we determine the earliest start time and the earliest finish time. So since B depends on A, we are going to look at if you finish A, you can start B. So the earliest finish time for A is the earliest start time for B. So let's look at the earliest finish time for A is actually 10, and this one, since we are talking about to B taking 7 days, so we shall just add here and we get 17. Then what else? We are saying that this one C depends on A, and since A is finishing on 10 days, then the 10 days, actually on the 10th day, that's when we are going to start C. So we are going to put our 10 here, then we add the duration here, we will get 22 days. So we keep on doing that. So we proceed. The earliest finish time here gives us the earliest start time for this activity D. And then when we add the two, we get 34. Then this gives us the earliest start time, and that is 34. Plus this, it will give us 60. Then finally, we have also that the earliest start time here will be 40 is the earliest finish time for this activity. We add, here we get 48. So if we get 48, remember this B, since F is the final activity or the final node, then we can bring it here so that we bring it to the end. Now, what does that mean? We are going to start now. This, what we have just finished is the forward pass. So this is the forward pass, which has helped us to determine ES and EF. So we go to the backward pass, and the backward pass, we are going to begin with the latest finish time for this final activity. So since the earliest finish time is 48, that's what we are going to take. We are going to take the earliest, the latest finish time to be 48 here. So what does that mean? So if you have 48, instead of adding now, you do the opposite of forward pass, so you are going to subtract. So meaning the latest start time for this activity is going to be 40. Then we come here, the latest start time is going to be the latest finish time for this activity. So this is 40 minus 4, we get 34. So meaning that this is 34 minus 12, we get 22. So this is also 22 minus 12, we actually get 10 also. Now let's look at this pass. If we use the other side, so the latest finish time for this must have been, must give us the latest start time for this activity. Since we see that this is the finishing activity and we see that this B is hanging, so we must connect it to the final node. So meaning the latest finish time for this activity is going to be 40. So when we subtract 17, we get, when we subtract 7, we get 33. Okay, so that's good. And then obviously this A depends on B and C. That's why you have to first finish this and that. But now, when we are doing the backward pass, what we do to get the latest finish time for this activity is going to be the minimum of the two values, the latest start time for this and for that. So if I compare 33 and 10, I see that 10 is the minimum, so I put my 10 here, so minus 10, I get 0. So that means our activity on node is done. So that is our activity on node. Now finally, we just have to copy this and put it on activity on arrow. So activity on arrow, we can just copy what is here. So we have 0, we have 10, we have 0, we have 10, then we have 10 here, 17, we had 40, we had 33, then we had 10, 22, 10, 22, we had 48 here, we had 40, we had 48 here, then 40, and so that's all. So finally, the other area that we need to work on is the table that shows us the earliest start time, the earliest finish time, latest and latest start and the latest finish time that will help us to calculate slack. And slack is actually telling us how much we can delay a particular activity without affecting the final completion date or without affecting the duration of the project. So we find that slack is the same as total float and is the same as LS minus ES, or you can take it as LF minus EF. So all these formulas must give you the same answer. So now we know already that this is 0, this is 10, this is 0, this is 10. That is for activity A. And for activity B, we know that this is actually 10, and this is 17, this is 33, and this is 40. And for activity C, this is 10, this is 22, this is 10, this is 22. And for activity D, this is 22, this is 34, this is 22, this is 34. And activity E, we have 34, then we have 40, we have 34, we have 40. Then activity F finally, we have 40 and 48, then 40 and 48. So if I make subtraction here, I get 0 here. If I get subtraction for this and that, I'll have 23. 33 minus 10. So then error S, this is 10, this is 0. And error S, 22, this is 0. 34 minus 34, this is 0. 40 minus 40, I get 0. So meaning slack, where slack is equal to 0, that is a critical activity. So if that is the critical activity, it means that the critical path is going to be comprising of, let me put this. So this is A. So we are going to A, to C, to D, E, and finally to F. So this is what we call the critical path. This is the critical path. So we must make sure that while dealing with these activities, we take a lot of care, because the moment we don't do any of these activities in their required time, then it is going to affect the final project duration. Now, we need to get the project duration. If we say we are looking at A, C, D, E, F. A, C, D, E, F. So the total time is actually going to be the total, the figure that we have here as the earliest finish time for this final activity. So what we are having here actually is, we see that we have 48. And therefore, since that is the highest that we can have, the project will have to take 48 days. In other words, project duration is 48 days. Or if you wanted, you could add the time of those activities. Let us see, if we used 10, we add 24, 12 plus 12, that is 24, that is 34, and 34 plus 6, that is 40, plus 8, that is 48 days for those activities that are on critical path. So that's all that we can do in this problem using critical path method and predecessor diagram method, whereby predecessor diagram method, we're talking about activity on node, and critical path method, we're talking about activity on arrow. So we said for the node, the activity is on the node. For the arrow, the activity is on the arrow. Like you can see A and its duration are on the arrow. This B and its duration, they are on the arrow. Then likewise. So here, this is telling you that This is a start here, and this is the finish.